Well, hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and today we've got a project that's actually going to involve some machining. We're going to have some lathe time and a whole lot of mill time. Sometime back I did a video on my mill vise itself, on the handle, replacing the handle that come with it. We've all accustomed to these knocker handles on the end and just how clumsy they can be. If you recall, I did a video on making or fabricating an existing hand wheel by boring it out, putting a 14mm socket in there, putting a handle on it, and it has served me well. And I will not be disposing of this. I will continue to use it occasionally, but it is very heavy, and there's been several times when it's kind of vibrated loose and hit the floor. Wood floor in here, so it didn't chip the concrete or it didn't break the hand wheel, but it almost got my toe. And like I say, it's plenty usable. I'll continue to use it, but for a new project, I wanted to try to make something a little bit different. I think all of you probably watch Adam Booth's channel, and you've seen him use his Edge technology two-way speed handle for his mill. I did some searching online, and let me say right to begin with, I'm by no means making these things to sell. So don't anybody get your panties in a wad over infringing on somebody's patent. But I did find that there are at least 3 manufacturers selling these, Edge Technologies, Gibraltar, and SPI, and they're all approximately $30 a piece plus shipping. I found numerous guys on eBay that are selling them for anywhere from $20 to $30 plus the shipping as well. But the issue with every one of them that I found was they're designed for the 6-inch Kurt vise, which has a 3/4 inch hex on the end. This is a 4-inch vise. It has a 14mm. It takes a 14mm handle, used a 14mm socket in the hand wheel. Now I did find one available. It's sold as under the Tormach name for the 4-inch vise. And it looked like the dimensions it gave in it were for thousandths, but I'm sure it was a 14mm as well on that. But it retailed for like $40. And either way, you know, I've spent the better part of a day working on this. I've actually got it built now. I'm recording this introduction after the whole process, but I know I've got probably 4 or 5 hours, probably 3 hours in it if I didn't bother with any videoing. So, you know, it's got to be a fun project for you to do it. If you've got other projects in your shop to do, by no means spend the time to build one of these. But if you need a little project, making this speed handle was fun for me. One of the things you'll see in this video is how to make this hex, how to turn this hex out on the mill. Using the DRO and a hole pattern, circular hole pattern, as a starting point. So I hope you enjoy this video, and we'll be back in a little while with a recap. I'm over here at the lathe now, and what we're going to do is make a shoulder bolt to hold the turning handle, the handle on the handle, if you will. The entire length will be 2.950. There'll be a 3/8 inch thread for 450 thousandths on here. Then there'll be a shoulder, and then from there to the end will be 2.5 inches. That will be the length of the handle, and the shoulder. This this shoulder at the end of the bolt will be completely recessed. We'll turn a slot on it or cut a slot in it, but it'll be completely recessed in the handle. Got a piece of material in the lathe now. What we're going to do is face off the end of it. Then we'll put a center in there. All right, I'm going to turn down at least about 3 inches of that. I'll set my stop right there for now. And we'll turn this down to 0.675, which is the largest diameter. All right, let's see where we are now. Of course, we got a long ways to go. We're at 810 now. So let's set a dimension. .675 minus 0.810. Set dimension. We've got 135 thousandths to go. So let's start with 60. And we'll get 60 more. Then we'll take a measurement. $690, so we need 15 thousandths. $673. That's perfectly fine for a shoulder on the bolt. So now we'll come back in and come to our end again. Set the DRO on the Z-axis to 0. Our drawing says we need to go 285 thousandths. I'm sorry, 2.800, 2 inches, 850 thousandths. Again, we'll double check that. That's 0. 208.52, that's fine. Now we need to take this diameter down to 0.453, which is a 29/64 bit. So we got a little ways to go. That's 611. So again, we'll set a dimension. 0.453 minus 0.611. That's 158 thousandths we need to take. That last cut I made just a 20 thousandths cut to clean it up a little bit. All right, so we need 453, we got 468 now. 0.453 minus 0.468, set dimension 15 thousandths. Okay, just double checking myself. All right, our last shoulder that we want to cut is the shoulder for the threads. And I'm going to have to extend my tool out just a little bit. Okay, I apologize some for the camera angle I've got on this. Realize you, with the tailstock in here, it's kind of hard to see what's going on, but I got the tool up against the end of the work now. We'll zero out the DRO again. And this shoulder will be for our threads, and we want to come over 450 thousandths. And again, using my carriage stop. And we want to take that down to 0.375 or 3/8. So I'll make a pass on it and then get a measurement. .431 thousandths. .375 minus 0.431, set dimension, need 56 thousandths to go. Probably going to take that in 2 passes. Leave about 25 thousandths. Still got just a little to go on that. Let me make one more pass. All right, this should do it. .374.75, so within 2 tenths, 2.5 tenths. All right, now what I'm gonna do is take my, let's see. I want to knock these edges off just a little bit. I believe I'm going to need to back the tailstock up so that I can get to them. And of course back the carriage stop out of the way. Put a pretty good lead in on that for the threads. Just touch it here, because I want to leave as much of that shoulder as I can. And on here I do need to put just a little bit of relief in there. Now I'm going to go get my my die. Instead of trying to set up for single point threading for this one thread, I've got a 3/8/16 die that I'm going to cut the threads with. And I'm just using the tailstock with the drill chuck in there to keep pressure on. And it looks like it's going to thread in there fine. Or cut. All right, that hit the bottom. Of course, I'm going to turn the die around to the flat side of it and run that back on as well, all the way to the end. All right, that's the bottom again. So I've got a good shoulder bolt now. I'm going to carry this over to the bandsaw and just cut this off and then bring it back over here in the lathe. I'm back here on the lathe now. I've got it cut off on the bandsaw. I'm just going to face this in here to dress that up. And we'll take a file and just round that edge, clean that edge up just a little bit. So here's what our shoulder bolt looks like. What we'll do now is carry this back over to, I'm going to cut this slot on the mini mill, but we'll go over there and cut a screwdriver slot in this. All right, I'm over around here at a little mini mill. This is an X2 mill, come from a little machine shop. And what I'm going to do is use the cut-off blade and put a screwdriver slot in that. So what I want to do is get this lined up with the blade, and I'm going to come down until I just touch the top and zero out the DRO on the Z-axis, of course. Now I'm going to let me do that again. I moved the wrong handle there. All right, yes, that's 0. Just touching is 0. Back this out of the way. Now come down until I just bring the Z back up until I just touch. And then use the half function on that. So, now all I do now is bring it back up to 0 on the DRO, and I will lock it down, and that looks plenty much in half. And there's 75 thousandths, which should be plenty sufficient for a screwdriver slot. All right, the handle on the handle, it's going to be made out of a piece of aluminum. See if I can give you an idea. Be 2.5 inches long. The large end, large diameter is 0.875. Small diameter is 0.750. That's approximately 1.5 degree on the compound. We're first going to bore with a 29/64 bit for our shoulder bolt that we made. So I'm going to face off the end first. Now, this being aluminum, I don't think there's any need of trying to drill a pilot hole through there to begin with. And I'm going to try to do this and leave the compound out of your way so that it's not, or the cross slide, so that it's not right in front of you between the camera. All right, I think I got it down about one more depth in there, and I'm going to slide the tailstock up just a little bit so that I be sure I don't run the quill all the way out of it. Now what I want to do is get set up with the boring bar to, I'm going to go ahead and do this end down here. Remember on our shoulder bolt, we want to do that so that this head fits flush in there. I'm going to take my small boring bar and I'm just going to do this and look at it, measure it, or not necessarily measure it, but just keep putting the piece in there and trying the piece. I will set my stop though. Yeah, wanted to be sure that boring bar would go in there, and it will. So I'll zero out DRO. And I want to go in 100 thousandths. Now that I got it close, I will give it a little measurement. That's 654, and we need 675. Let's try setting a dimension on that. All right, so we got 21 thousandths to go. I set that on the wrong axis. Okay. I'll just use my dial. That's good. I'm going to go in just a little bit deeper just to be sure that it's beyond flush. That looks good. Now, I'll chamfer that inside edge there. Now what I'm going to do is just make a small pass over this just to get it round and to get a dimension before we start laying out our actual taper. The handle needs to be 2.5 inches. So I'm going to set the 0 on the Z-axis right there. And come in to 2.5 inches. And put just a tiny witness mark right there. Now I need to do just a little bit of calculation, so I'll be right back in just a second. All right, I measured the diameter of our piece, and it was 986 thousandths. And what we want on this small end is 756 thousandths. So I'm going to take the parting tool. I've got it squared up with the vise. I'm going to plunge in 236 thousandths right here. That will be the bottom of our narrow side. Got the DRO set. All right, I will see, but I don't think the caliper jaws will go down in there. Well, maybe they will. And that is exactly 750 thousandths. So now we want to set the compound at 1.5 degrees, which is really not that easy to see. Now it's not very easy to, there's no minute adjust on this, so it's kind of set it by eye. And I'm pretty sure that's close. But what I'm interested in is keeping this small side, small end to that dimension. This one out here can run a little large, a little small. That end doesn't matter. This will match our handle itself. So let's start cutting the taper. And I should have maxed out my cross slide before I started that. All right, that's max on the cross slide. So I'm just going to go ahead and lock the carriage down right here because we won't be using that. This should be the last pass here. So I'll just bring it into where it touches. All right, I'm very well pleased with that. So let's put the parting tool back on. And we'll just set the drill bit in there just to keep our piece from falling. Turn our RPM down a little bit. All right, that's a little bit worn. All right, I got it deburred now. And that comes down in flat, flush. As we see, the shoulder on our bolt is just a few thousandths longer. And that way this will bottom out on the handle and allow the handle on the handle to actually spin freely.